more sold, but each seller sells a little bit less.
Overall, I'll repeat that. Overall, stuff is sold more, but each seller is going to sell less. This is counterintuitive. You want your crocodile brains, your I need to get to the answer quickly brain says more, everything's more. But economics will clearly show this in easy mathematical terms. So first, let's draw supply and demand as a review to get your brains warmed up today. Supply and demand. So what shifts when the number of sellers goes up? Okay. I'll take a volunteer. Yes. Supply. Okay. Does it shift to the right or to the left? Right. So we're adding up more horizontal sections for you. So you are absolutely correct. Is your name start with an F? Felipe. Okay. So S prime. Okay. So what happens to price and what happens to quantity? I'm going to kick it all the way over here. Darian, what happens to price when we move from the old equilibrium to the new equilibrium?
The price will decreases.
Price decreases. Okay. Price decreases. And the quantity to the row behind? Quantity increases. I don't know why I drew two arrows there. Too excited. Okay. Quantity increases. Okay. So this is the new point and move that way. Okay. So the price decreases and the quantity increases. Now, underlying the supply curve are individual firms that are thinking they want to supply the good. So this is in the market, and if I mentally zoom in, individual supply curve. The individual supply curve might look something like this. Does the individual supply curve change? Now this is something I haven't forced you about. How does the individual supply curve change? Now we can think in the willingness to accept. See, you will, just one second. The willingness to accept, ask the question, at these different what-if prices, what is the quantity that the individual seller is willing to sell? So none of the input costs have changed. As Felipe absolutely said, we're adding up more of these. Okay. So let's give a numerical example. And you should be able to do this. There's nothing new here. It's just putting it together in all the steps. So each seller has a supply curve of Q equals 2P. Each buyer has a demand curve of Q equals 30 minus 14. There are 10 sellers and 20 buyers. What is the market equilibrium? That is one of my favorite exam questions of supply and demand because it forces you to use a little math, a lot of thinking. And I've just asked you to get to the answer without showing you the steps, so I'm testing whether you can slow down and do the steps step by step. So the economic steps is you need to get two equations for market demand and market supply. So this is sort of a table of contents or preview of the steps we're going to do. Once we have two equations and two unknowns, we go into math mode and solve it. And then we have to go back into economics to interpret what's going on. So let's do supply and demand. And then we'll have a space where we do the market together. Otherwise known as equilibrium. So what is the relationship between Q market supply, and Q individual supply? I see hands, but I'm going to. So when we have two people, we graphically add them up horizontally. What do we do equation-wise? Justin?
You multiply?
Multiply. Multiply by what number in this case?
It would be 20.
I'm on the supply side.
Oh, I'm sorry. It would be 10.
You just good? Times 10. Okay. So on your crib sheet, you need to say slow down, supply sellers. Don't forget that. I want to give you all the points you can. So Q individual supply is going to be 2P. Market supply is 10 times that. So I can do Q market supply is equal to, I'm just going to do it all in one step, 20P. What if I made a little table, prices and quantities of individual and quantity of market? This is a good way to check in case you did some math wrong. Okay? So on a price of 5, I'm just picking a random price. The individual supply is going to be 10, and then when I plug in 5 to the market supply, it's going to be 100, and that works out because there's 10 times the sellers, adding it 10 times horizontal. Duke, do you have a question?
I was just going to ask you to please zoom in a little bit.
Yes. How's that? Okay? Thank you. Other people were thinking the same thing. You had the guts to ask. Okay? What do I do for demand? Duke gets a pass since he asked. I'm going to go with the remainder of the back row. What is individual demand? Someone just say it out. 30 minus 4p, okay? And what is the economics for the market demand? What should I write there?
The individual demand times the 20 buyers.
Times 20. 20 buyers. Absolutely correct. And now I just do the algebra. So math mode, Q markets, demand equals, so times 20, I have to times 20 of each part. So that's going to be 600. If you don't like this is where students start bringing calculators to class and using them. Okay, 600 minus 80p. This one is easier, but we'll need more calculators as we do elasticity. Did I do that correct? Do you agree, or did I do it wrong? Okay? And if I want to check it, so this is the paranoid section here. If I want to check it, P, Q individual demand, Q market demand. Okay. What number do you want me to plug in there? It'll work for any number. 15, okay? For a price of 15. 15 is a little too high because it goes negative.
4.
So, great, 4, thank you. Any number of which that's going to be positive. So, you pointed out, you helped me teach today, you pointed out the exception. So, for the individual, it's going to be 30 minus 16, or 14. Okay? When I plug in 4 here, 4 times 80 is 320, 600 minus 320, 280. Is the relationship 20 times? Yep. Okay? So, we're good. And if I want to do this graphically, like you did on the homework, where it exactly doubles or exactly triples, you take the quantity at every price and you double that quantity or triple that quantity, or in this case, times 10, 20, or 10 that quantity. Am I talking too fast? Good. Thank you for the ones who shook your head. Shaking your head this or this is helpful. Blank stares, I can't read your minds. So market equilibrium. What do? For market equilibrium, I do the only thing is market supply equals Q market demand. That says market. Okay. I could draw a graph, but that's a little slow. I can do it much quicker just by setting the two equations together. 20p equals 600 minus 80p. So plus 80p on both sides. 100p equals 600. P equals 6. Okay, the price is $6. Okay? So now I've solved the initial condition. If I go back to this concept check, all I've done, I haven't done any shifts yet. So I just figured out the price that it's going to be. Oh, I should also solve what the quantity is going to be. I can plug in this, because it's the intersection of two equations, I can stick 6 into either of these equations. But if I want to be sure I did my math right, I can stick it in both. So 6 into here gives me 120. Oh, move the paper. Thank you. There we go. Right? Q equals 120. And if I plug 6 into there, 80 is 80 times 6, 480. 600 minus 480, 120. Okay, so I'm good. Okay. So if you are unsure, these are the sort of safety checks. So plug into both for safety checks. So this is safety. Okay? So getting back to the original question, if the number of sellers goes up, the supply will shift to the right, and in equilibrium, each seller will sell more. So if I go to this situation, I need to test this idea numerically, I need to increase the number of sellers. So show math on board was just you on board. So now suppose there are more sellers, but the same number of buyers. So 20 sellers and 20 buyers. I'm sorry, let me finish my sentence and then go back. So now the number of sellers has changed from 10 to 20. Okay? I haven't changed anything with the number of buyers. What is the market equilibrium? Does each seller sell more or fewer? I don't always write market and demand. It's usually context specific. If you're ever confused, raise your hands. We have the new price being lower, and each person's buying more. I think it's all clear, but you're going to tell me if there's something not clear. Okay? Will.
Now, you have the individual supplier curve from the sheet before. Yeah, that one. Is that going to match is that curve going to match the people that are just entering the market as well?
So
like
if
the people that are already in.
Did this to scale, I would have. Let me do it to scale because this is less confusing. So Q, the market, was 2P times 10 for 10 sellers equals 20P. And now Q market supply new is going to be 2P times 20 equals 40P. So if I drew it exactly to the equation, I would do this. And then for any price, say a price of $5 instead of 100, the price of $5, it's now going to go to 200. And 0 would still be, if I plug 0 into each of these. So this would be the new supply curve. That would be if I drew it accurately. Before, intuitively, it doesn't matter. In this case, intuitively, if we have more supply for whatever reason, it's going to shift right. This just gives us the direction. So these graphical things are good for direction.
I'm asking more about like that, the individual supply curve that you drew. That would be for everyone in the market, correct?
Each person in the market has the same individual.
So even the people that are entering, they had the same
yes.
supply curve as the people that were already in it.
So students often ask that, and so either in the exam I will say each seller is the same, the old sellers are the same as the new sellers in this supply curve. If I had a different supply curve, then you would just add up the Q equals 2P times 10 plus Q equals 7P times 10 if the new sellers were different types. So I didn't write identical on here. On the exams, I usually make it a point to write identical, or someone asks during the exam and I write identical on the board. So I want to eliminate all uncertainty related to just language and how you get all the economics. I'm going to stop asking, is this solid? Because I don't expect you to have it solid on the first try. But are you on the path to solid? Is anyone not on the path to solid on this? And has a question that will help them get to the path to solid? Okay. With that, you know everything we need to know about supply and demand to talk about very interesting things. So as a review, we have demand and supply and shifts in demand. Supply and shifts in supply. Do those first. Then you get market equilibrium. You can see how the market equilibrium changes due to these shifts. You need to understand consumer surplus and producer surplus, and how it relates to willingness to pay and willingness to accept, and these price floors and price ceilings, and excess supply and excess demand. We also have some unintended consequences, because when you have a price floor and you raise the price above the equilibrium price, some people aren't going to get to sell it they used to get to sell it, so they're not happy. So that's something that goes on. And that's one of the neat things about economics. because we're using ceteris paribus and can look at just a few parts moving at once, we get to see the unintended consequences. Versus someone in government might just say, we want to help the farmers, so we're going to raise the price of corn so that they're happier. Not all of them are going to be happier. The ones that get to sell, very happy. The ones who don't get to sell anymore, not so happy. Did you? I love the side talk if it's related, but do you have a question you want to share with the class, or you're good?
You're just going over price,
Okay, great. Okay, stick figures if you forget. Okay, and these are a bunch of questions. So now I'm going to move to the next section of class, elasticity. It took a while to get here, but I'm very happy with the learning outcomes so far. So, there are ways I can get, like giving you before class quizzes so that we can get through elasticity a little faster. So elasticity, the number one thing I need you to remember is elasticity has a meaning. It means stretchiness. Okay, if you can remember elasticity and stretchiness, like an elastic waistband, when I get old and fat, I'm going to need one. So if you can remember elastic waistbands, elastic stretchiness in economics, you will do a lot better than the people in Cal's or Yale who will just remember the equation and forget all the intuition. Okay? So in line with that, elasticity is like Elmo. And the two words you need to remember with this, Elmo says force and adjustment. So if I take an intuitive idea of what elastic is, for those who are kinetic learners, is the elasticity of an object. I have here something that may or may not be elastic. You already, from your everyday life, know it's elastic or not elastic. And when I apply a force to it, okay, if it's, this is stretching, because it is elastic. It is a rubber band, the definition of elastic in physical terms, or archetype of elastic, okay? So the force we apply is going to be price. If we have something that's not elastic, like this USB cord I grabbed from my computer, okay? When I do this, it's not going to stretch, right? I'm applying a force, it's not stretching. So elasticity is used in economics where we apply this idea of a force that's a price, and we figure out what's going on. So let me just say again, elastic, you apply a force and look at how much it stretches. So I can use the word adjustment instead of stretch, and it's adjustment divided by the force. So if there's a lot of adjustment for the same amount of force, for a given amount of force, we say it's very elastic. If there's very little adjustment, we say it's not very elastic. So this is just a physical understanding of elastic. In this next slide, almost all the words are going to be the same. Oh no, sorry, I didn't repeat the visual. Okay? But in economics, the same idea is used. So we apply a force, which is going to be a percent change in price. Okay, it's the force, and the adjustment is the percent change in quantity demanded. And so you all did the before class quiz. You remember there's a percent change in quantity demanded on top and a percent change in price on the bottom. So this is the force we're applying. This is the adjustment. Okay? So it's a measure of the responsiveness of quantity demanded to changes in price. Okay? Sometimes we write in front of it the word price elasticity to emphasize the force we're applying is price. In about 40 minutes or 20, 30 minutes, I'm going to apply different forces like income elasticity or cross-price elasticity. Cross-price elasticity would be the price of another good. So when we don't write the word price there, we always mean elasticity of demand, the vanilla version, which is we change the price of the good we're thinking about, and we look at the percent change in quantity demanded of the good we're thinking about. The final thing is we use absolute values, so we don't have to use negatives all the time. But in a demand curve, whenever we increase price, fewer people are going to want to buy it. So these two things are always going to be of different sign. And we use this absolute value to give us the correct sign of it. So another way you can do it is you can remember it. It might be helpful for the like rules to help you. Instead of having a rule saying, I need to remember price going up means quantity goes down, just take out the absolute value sign and put negative in front of it, which tells you just flip the sign of the other thing. Okay? So price elasticity is this adjustment over force. Why do we use elasticities? It's not just because we like to give you more vocab and is job security. It's in fact, the goal is to describe how supply and demand changes as price changes for a good or service, but to be able to do so across lots of different goods. So one option to do this, the option that all of you want to use and already intuitively know, is to use the slope. But the slope is not a very good measure because if we have a hotel, a slope would mean 50 fewer rooms demanded if we raise the price of $1. So that might be one example of a slope. A restaurant might be 50 fewer diners if we raise the price for $1. But the problem is we don't know if 50 is big. You know, is 50 diners big? Is $1 big? It depends where we start out. But for a restaurant, $1 might be a pretty big deal. For a hotel, $1 is probably not going to be a big deal. 50 rooms, if we're thinking about the whole market, for the roughly, I forget my numbers, I think 10,000 rooms in Las Vegas, it might be more than that, probably more than that. But 10,000 rooms in Las Vegas, 50 is going to be very small. If we think of one hotel, or one hotel, 50 rooms might be pretty big for a small size hotel. Okay? So in order to give us a sense of how big the change we're applying is relative to the thing we're looking at, we just use percents. So the other very important thing is we use percents. Because now we can say, with elasticity, if we apply a 1% change or 10% change, we don't just talk about the absolute value of $1, which could be 1%, could be 10%, could be 100%. For candy, an increase of $1 is going to be big. So the formula for elasticity, I'm not entirely even sure that this is in your packet, but I include it here for the people who get mixed up organizationally. To find the elasticity of demand, we take two nearby points, just like we do with the slope. But instead of looking at the change in price and change in quantity, we want to find the percent change in price and the percent change in quantity. So now is a good time, if you have a calculator, bring it out. So I'll do this first one as you bring out calculators. Going from 50 to 51 is a change of +1. +1 is what percent of 50? Well, I know in my head, +1 out of 50 is like +2 out of 100 ratio-wise. So that's going to be +2%. What do I do here? Well, I make sure I go the 2 minus the from, so this is -50. -50 divided by the starting point, which is 1,000. So -50 divided by 1,000, and then convert that to percent. What number do we get out? 5%. Okay, 5%. Don't need to use your when in an exam your brain is doing a lot of things. Let the calculator do the math. Okay. So if we have these two things and then we apply it to the formula, it's going to be -5 on top. And the force that we apply is going to be the +2%. The -5% could be the adjustment. This is just writing it as a dividing sign. In your notes, you can write it on top and bottom. And then we take the absolute value or remove the negative, and we get the elasticity is 2.5. There are no units to elasticity because we're able to compare percents with percents. So we can use this across industries. We can look at what's happening in the hotel industry, in the airline industry, in the electricity industry, similarly, by using this phrase elasticity. We can't compare electricity in hotels because if we use slopes, because we'll do 1 gigawatt hour for $1 versus 1,000 hotels for $1. So what does that mean? Justin?
So when you ask for the percent change, then we can use signs, just not for elasticity. Then we use absolute value.
So the percent changes will absolutely have signs, and you have to keep track of that. But when we ask you for the elasticity, we want the absolute value. This is just convention. If you read a book and they use a negative sign there, all they did is they didn't do the absolute value. Okay, and nowadays, I think the teaching profession has decided everyone should make an absolute value, so we don't have to say, this is the reason why you use absolute value, because an elasticity of 5 is more elastic than 2.5, and 5 is higher. But if you use negative numbers, then we have to say farther from 0, it gets confusing. So we just use, an elasticity of 5 would be higher. Okay? So another way I could use it is I could give you the elasticity and just give you one of these percent changes, and you could compute the other percent change. So that would be another way to use this formula. So it's just a formula with 3 unknowns, and you need to take, if I give you any 2 of the unknowns, you should be able to give me the third one. So why don't you try this, okay? So sometimes I might give this to you. I'm going to give you very little time, and I want you to flag me if you don't think you can get any confused, so I won't call on you. Okay? So using this demand curve, graph it and find the elasticity at QD equals 100. The one thing you need to know is you can use, you apply a force, right? This little weighted, like my elasticity force machine. You apply a force. You can either pick a percent change in price, or you can pick any change in price. So actually, those of you who are using, actually, why don't I have the middle section use 1, the section to the left use 5, okay? And the section to the other side use -2, okay? So first, I'll do the first part for everyone. I'm giving you the point that I want to start at, but I haven't given you the P. How do I get the P? I'm just reading it from the graph if I graphed it, or I plug it into the equation. So the starting P is going to be 100. Okay? Now I apply a force. So the middle part of the room is going to be 1. This part's going to be, my short-term memory, 5, plus 5, and then -2. So it's going to be 101, 105, and -2, so 98. Okay? Good. Okay? Then you have to go and figure out what the QD is, and then you have to do the 2%. Okay? I'm going to walk around. If you're confused, choose when you're flat.
Can you give us again? 1?
So then we do
Yeah.
200 minus 101.
Oh, we have to draw it.
Wait, P would be 100.
P would be, wait, P's 100 or 101?
Oh, wait, initial is 100.
Huh?
The initial P is 100, the next is 101. Since we have 2 numbers in each.
Oh, we're trying to find the change.
Oh, yeah, okay. Okay. So because the change in P is 1, so it would be the next, like, P
1 divided by 100.
1 would be, P sub 1 would be 101.
So it's 1%.
Takes a sec. It's the elasticity of the percent change in premium demand. Wait, what's the second quantity demanded?
Huh?
What's the second quantity demanded? Oh.
Wait a minute. So the change in percent we're saying is 1%?
Okay, so, for the first P, you would plug it in to the equation, so it'd be 200 minus 100 would be 100. But then since it says use a percent, or use a change of
You can do this graphically.
the
Graph it and
next,
then
like,
find the
P sub
elasticity.
1 or P sub 2 would be,
In the note, so I just realized in the note packet, I
and then
give
when
you
you plug it
space
in,
to
it
graph
comes
it.
with the
If
second
you're not graphically
quantity
oriented, you don't have to. You can do whatever you want.
Sub 2, whatever.
But
It
it's
would
helpful
be-
to see it.
What does that mean? What does that mean?
It means like the second,
200.
the second
200.
value
Oh.
would be 200
So
minus 101.
let's get back
So
together
then-
and breeze through this. I started with a Q of 100. I used my magic equation machine to give me the price. It's going to be 100 here. I'm going to do the hardest of the 3 and pick on this side. Pick on you so you learn more. So what did I tell you? What force did I tell you to apply? What is the change in P that I told you to apply? -2, okay? So, do I take this and then move it to the left? Is that correct? No, okay, oh gosh, I messed up. Okay, I move it down to 98. Whoops, 98. Okay, so how do I find that new point? So this is my old point. This is my new point. Okay. What's over there? I'll ask Ridge. Is it Eric? Eric?
Nick.
Yeah, sorry. Ridge, Nick, and Brett. What's that new point for Q? 102. Okay. And then I have to figure out what's the percent change in price and what's the percent change in quantity. Okay. Felipe, you want to close this out or you want to pass? Okay. Yes, they are both of size 2%. I'm going to ask Megan, which one's positive, which one's negative? Okay, minus 2%. Okay, so in this case, the elasticity of demand, I use this funky looking E because we, which is how I learned it. A lot of people use for elasticity. Epsilon, if you're into Greek letters, lowercase epsilon. And it's going to be now plugging into the equation, minus 2% over plus 2%. Elasticity of demand is 1. Yes. Will?
Is the elasticity just the slope?
The elasticity is not the slope.
It just happens to be in this one?
It happens to be the slope in this one. Okay? Just happens to be the slope. It is not, it's absolutely not the slope.
Okay.
Okay?
So what does it mean if it's one?
Okay. If it was 1, it means from the equation of elasticity of demand, it means that the top and bottom are the same size. It means anytime I apply a force of, say, 3%, I'm going to get an adjustment of 3%. If I apply a force of 1%, I'm going to get an adjustment of 1%. If I apply a force of 1/4%, I'm going to get an adjustment of 1%. This is an approximation. If you like calculus, it's the limit as if you go to small things, and it's an approximation. So we want to use it for small percentage changes, but it's a very good approximation, and it's useful for doing something with revenue, which you did on your before class quiz, and I'll get to it in a second. So very good question. Yeah, Brett?
Yeah, I was going to ask, like, now that we decided we came out to this one, after we apply that, what are we going to apply that to one?
Okay, suppose I then say, tell me, with a percent change in P of 5% plus 5%, what is going to be the percent change in Q? If we know that the elasticity of demand is there.
So it would be elasticity of 1
So 1 equals 5 over something else.
That would be, so then it would be -5.
Negative 5. Okay. In this case, when it's 1, it's very easy, and you think everything's easy, the answer is always 1. The answer is not always 1. So if the elasticity of demand were, if I told you the elasticity of demand were 10, okay, and then I say percent change in price, if I want to raise the price by 1%, what is going to be the percent change in quantity? So if I raise the price by 1%, is quantity going to go up or down? That's the first thing that everyone forgets.
Down.
It's going to go down, so we need to make sure that sign is different. Okay? And then the elasticity of demand tells me, oh, I applied a force, my adjustment is to be 10 times as large, minus 10%. If I told you this was the elasticity of demand when P equals 1,000 and Q equals 17, crazy numbers. You can't use those numbers. They're not numbers I see all the time. Doesn't matter. You take, if I give you these things, then you can, given these things, you can calculate this, and then also given this, you can calculate the new P and the new Q by just applying the formula. So 1% more on P would be plus 10. I did that very quickly. You can do it in the math quiz if you need to, more slowly. And then minus 10% of this would be minus 1.7. So this would be 17 minus 1.7, and this would be 1,000 plus just keeping things organized. I haven't explained why this is useful for economics. This is useful for math, getting you to do a bunch of math equations. We'll get to the economics next. Yeah. But first we need to learn the vocab.
So you want in a company, you want the most elastic, so the closest to zero would be the most.
So a company, that's a great question. So what would you rather? If you're thinking about, if you have two industries, you're thinking about buying an industry. Okay, you're buying a company, and in one company, when you raise the price 1%, the quantity drops 10%. In the other company, you raise the price 1%, the quantity doesn't drop at all. Which one do you want? You want the one where the quantity doesn't drop at all. But that's not always, that's if you're thinking about price raises. You can also have, if you have a very high elasticity, so suppose my elasticity is very high. If I drop the price, when the elasticity is high, when I drop the price, I'm going to get a lot more customers. So Will's question is, when you're considering price increases, you don't want a lot of quantity decrease. Okay? So I'll even write that down. So company what ifs? Price goes up, you want quantity, you're happiest if quantity doesn't drop. Okay? And if the price goes down, like you do a little bit of a sale, you want the quantity to go up a lot. Okay? So this one is going to be, you apply a force, not much adjustment, so this is going to be low elasticity, low elastic. And this one, you drop the price, Q is going to increase a lot, you want high elastic.
So I was just reading an article online that it said, I think it was McDonald's, like their pick 2 meal or whatever, they're raising the price from like $2 to $5.
Okay.
But like wouldn't that be like way too much? Like why would they do that if like their quantity or like the demand's gonna go like way down then, wouldn't it?
So they're probably hoping, if they're raising the price, they're hoping that there's a low elasticity. They're hoping that not a lot of customers are going to switch. I don't know the exact pricing details,
Yeah.
so 2 to 5 seems big. I think they're doing like bundle deals or something
Yeah.
like that. And they're trying to push their premium good. So that brings in a lot of things. But McDonald's is one of the world experts in menu design. And they test the heck out of these things. And what they do is they actually run experiments where they change the menu prices of one of their items, and they see the elasticity of that item. And then they don't mind as long as people then shift to another good that's also a McDonald's. So that's cross-price elasticity. So raising the price of McMuffins gets people to buy more hash browns, okay? Or some other breakfast sandwich. What they, and we'll get to that in a second. Does that answer your question?
Yeah.
Enough? Okay. Good. I like it when you bring stuff in too. Brett.
Yeah, so I was gonna say, like, let's say they lowered the price of like the main dish, the hamburger fries, and like, so if it had high elasticity, will that mean that they'll sell more desserts essentially?
So the elasticity is always on a single demand curve. So we're just thinking about demand itself of one good. So for now, with price elasticity of demand, or the elasticity we've been talking about, if they lower the price of hamburgers, they're thinking, how many more hamburgers can we sell? There is a thing called cross-price elasticity, which says, lowering the price of hamburgers, how does that affect ice cream? We haven't gotten to that, so you're just thinking ahead, which is good, but keep the two separate in your head. We need to go a little deeper in elasticity of demand before we can talk about the other things. Okay. So graphically, you apply the force, you do percent, the elasticity is 1. And a note on calculating, remember calculating percents for math is 2 minus from divided by from. Sometimes I'll give you a percent change, and I'll give you the from, and you have to compute the 2. So you can use this equation as well. Percent change. The book uses 2 minus from divided by the average of 2 and from. So if you're reading the book, you'll see a difference. The numbers will be a little different. but it's only going to be, the top one is standard in business. They don't do the bottom of the fraction, they don't use the average. So I teach you this because this will make your bosses more happy, and this will make econ professors more happy, and these people pay you, and these people you pay. So, the book definition is not terrible though, because if we think of elasticity, we have to think of small changes, and because we use elasticity in marginal decision making. So marginal, again, is that vocab world we use in marginal utility and marginal willingness to pay. We're thinking about small changes in this what-if scenario. So if we have a small change, the to and the from aren't going to be that different, so the average is going to be very close to either the to or the from. So if you calculate it wrong, but you're within, say, 5 or 10%, I give you the points. But you have to show your work. If you just write the answer, and I can't tell what two numbers you put in, then you're just taking a risk that you're doing it the right way. If it's really within 10%, then that's fine. If it's not, just show your work. Show your work. It makes my life better. It makes all the TA's lives better. Okay. So the categories for elasticity just have to do with these are just vocab words. So elasticity ranges from 0 to infinity. These are not new words. I mean, I guess they're new words because you don't use them a lot of the time, but you can just use the ideas of understanding, applying a rubber band and a force. So let's start with these two. 0 elasticity we call perfectly inelastic. That's where a small change in a small percent change in price, the thing at the top would be 0, would get us an elasticity of 0. Okay? Infinity is perfectly elastic. So for a given small change in percent change in P, so 0.00001%, I have a huge change in quantity. Okay? Quantity demanded. So that's how I want you to understand it. Okay? For something that's 1, that's a special vocab word. It ends up being that these two are the same just by the definition of the of elasticity, and we call that unit elastic. Anything more elastic than unit elastic, we call elastic, and anything less elastic than that, we call it inelastic. So if you want it in a graphical form, 1 is unit elastic. Anything greater than 1 is elastic. And then infinity is perfectly elastic. And then less than 1 is inelastic. And 0 is perfectly inelastic. So they don't go negative because, well, first of all, we use the absolute value. But the slope is, they don't go negative because the thing at the top and the thing at the bottom are always the same, are always opposite in sign. So when price goes up, quantity goes down. So in order for it to go negative, it would have to kind of flip, and I'd have to take out the absolute value. So there's nothing really deep here. Just remember, no negative elasticities. Okay, next.
Bottom one is for a given small percentage fee. Should that be a large percentage fee?
So I just use the same thing here for small. But so I could change this to a large as well. So for a given large percentage change in P, the percent quantity in it would also be 0.
But why is it small on the side?
0.
Well, you can take out the word small here. The small here is just emphasizing we're using this to kind of get a sense of the responsiveness of demand to price changes. Here's the easy story. If the price is starting at $100, we don't want to use a price change of minus $90 because that's too large of a price change. So we want to use things that are small relative to where we are. I'm not sure what I said to clear that up, but you're welcome. Okay. So if I pick an arbitrary point, it's going to look like things that if I take this point at 30 and 30, if I increase the, let's apply a force of a change in price. So I'm doing a change in price of 10, which is pretty large, but I want it large enough so you can see it. How much does the Q change? It doesn't change by very much. It changes from 30 to say 28. So in this case, it would have a pretty inelastic. The adjustment is pretty small. If I go to applying a price and having no adjustment in quantity, that's perfectly inelastic. So that was the before class quiz question about inelastic. Perfectly inelastic, looks like an eye. So the memory tip, and I use this, so you should use it too if you need a memory tip. Inelastic starts with an eye, and the eye is vertical, and everything is happy with that. But you need to understand that memory tip and also applying the idea of a force. I apply a force, the percent change in quantity is not very large. So not very stretchy, inelastic. Okay. If I have an elasticity of 5, starting at 30, if I apply a force of plus $2, it's going to, I can calculate the percent and then calculate the percent change in Q. It ends up plus that amount would give me a percent change of this size. So elastic generally looks flatter. Okay? But I want you to put an asterisk and don't memorize flatter. Okay? Don't memorize flatter. Okay? Because I'm going to show you something that's going to contradict that. Perfectly elastic is always perfectly flat. It's perfectly flat. And then finally, unit elastic, you could pick a point, apply a force of apply a force of price, and then calculate the change in quantity, and make it so that the elasticity is 1. This is just, I kind of already covered this. We use elasticity like the slope, so if we're considering a change of price of 1%, we can then compute the approximate adjustment of the percent change in quantity. So given the elasticity, you can plug it into the equation to get the size of the other thing. So if I were to give you it as an exam question, I would not give you this section. I would just give you what's on the left, and you would fill in this table to the right. So the thing is, remember when P goes up, Q goes down, and generally when we're using a slope, we don't want to use very large numbers. We don't want to increase it by 500 if we're starting at 500. So do things that are smaller percentages. Max.
For approximate adjustment, because it's absolute value, how do you know if it's plus or minus 5%?
So, good question. How do we know that whether it's plus or minus 5%? Remember, P goes up. When P goes up, Q goes down, so it's always the opposite sign. So you just have to remember always the opposite sign, or change your elasticity formula so you always use negative the ratio of the percents. So that negative will help you remember to always flip the sign. Elasticity and revenue. Okay. You're going to do this a lot during the Friday discussion, so I'm not going to go through this. I'm not going to go through this, except to say, if price goes up 10% and quantity goes down 0%, which way does revenue go? Is it up or down? Up, okay? Not a trick question. Selling the same number of units and higher price. It's going to go up. Now, what if I have Q go down just 1%? So this we like. We like the price going up as a company selling goods. We don't like the quantity going down. But when it's 1%, then this is going to be higher in magnitude. So let me just write signs here. So this is going to be higher in magnitude, hence the overall effect is going to be positive. Okay? And then I'm going to add a third option, A, B, or C, right, or 0. Even when it's minus 8%, it's still going to be positive. The magic thing about percents is when we use these percentages The thing that has a higher percent change tells us what's going to happen with revenue. And you will see this very clearly in the Friday discussion. Or you can just plug in numbers into your calculator, like 747 times 18, and then apply these percentages. So 7047 times 1.1, which is 10%, times 18 times 0.98, which is 8% less. When you do this, this is going to be, the direction it's going to go is going to be given by whichever one of these is higher. And you will do this in class, in Friday discussion. Okay? So, great. So we're going to use that when we talk about some revenue ideas in a second. So this slide says on a line, so this is where I need you to remember the slope does not tell you the elasticity, because the slope just tells you the ratio of a change in x and change in y. The elasticity talks about percents. So elasticity varies on a line, slope is constant, but elasticity varies because $1 and 1 unit may sometimes be big and sometimes be small in percent. So this is something you need to be able to remember. The middle is unit elastic, up on the top is elastic, the bottom is inelastic. So I'll let you write that down, and then I'm going to tell you a story about it, or tell you how to think about it. Let's say I'm over here at 50 quantity and 10 price. Okay. The slope is the same everywhere, but here it's 50 quantity, 10 price. So the slope is -1, so every $1 up, one quantity up, $1 down, or $1 down, one quantity up. So suppose I apply a force of increasing the price. I could do an increase or a decrease, it doesn't matter, I get the same elasticity number. So -$1 plus one quantity. But this -$1 is off of a base, a starting point of 10. So -$1 out of 10 is 10%. That's a pretty big change in percent change in price. But up up one quantity is 1 plus 1 in quantity out of a base of 50. That's just 2%. Or that's a pretty small percent because the base is very large. So in this case, a pretty large change in price is going to have a smaller percentage change in quantity. Therefore, I apply a force, the adjustment small, inelastic. If I go up here, then we have the opposite story. I change the price a little, the quantity is going to shift to the left, the same amount, but plus $1 out of 50 is 2%. But minus one quantity out of 10 is minus 10% in quantity. So small percentage change, big quantity percentage change.
This only applied to supply curve?
This is just for demand curve.
I mean, demand curve. For elasticity, would you ever apply it the other way, or no?
I'm sorry, I don't understand.
Would you ever apply, like, to the supply curve?
Yes, we will do a
Okay.
supply curve elasticity. So this tells me, and I kind of hate it and I kind of love it, because I hate it because this is something everyone just memorizes. But the thing I want you to know, so you can make a lot of money when you're a consultant and just buy me some chocolate, like I bought you, is you want to understand it doesn't matter up a dollar how much over in quantity. You want to think percent terms. The percent term is going to tell you everything that's important. So built on this, we're going to do our first module, which is revenue, and then determinants of elasticity of demand. Revenue is price times quantity, P times Q. The elasticity is 5. We're asking the question, how much does the change in price affect revenue if it's positive? So using this idea, if the elasticity is 5 and we apply a 1% force up, we're going to get a 5% force down. That's just using the percent change. Okay? And I want to give, so I realize I'm running low on time. I still have 5 minutes, or a little less than 5 minutes. Let me just show you, I tend to want to show you in words and then show you the picture, so I'm going to show you the picture and then go over the words. So this is the revenue curve relative to that price, okay? Sorry, to that demand curve. So the revenue is, if I take 50 times 10, I'm going to get 500. If I take 40 times 20, I'm going to get 800. If I get 30 times 30, I'm going to get 900. And then this is, once I go out here, it's going to start dropping from that 900 because 20 times 40 is going to be 800, 10 times 50 is 500, and 0 times 60 is going to be 0. So this is just a mechanical relationship. I'm figuring out the revenue graphically would be price high and quantity wide. You'll get to see that in Friday's discussion. The magic thing I want you to think about is in this inelastic region, let's say that 50, if I start at P equals 50 and Q equals 10, and I apply P to 51, and then Q goes down to 9. Right? Just from the equation of that line. So this is old and this is new. This is a plus 2% change in price. Percent change in price. This is percent change in quantity of minus 10%. So as a business person, if I'm at this point and I'm thinking, if I raise my price and lower my quantity, nope, I'm sorry, I'm in the wrong side. So if I'm starting up here and I raise my price and lower my quantity, okay? If I raise my price and lower my quantity, am I going to increase or decrease my revenue? Well, from this graph, it shows you that if I increase the price and decrease the quantity, I'm going to be moving left. And on this graph, which just says quantity here, moving left tells me I'm going to go down in price. Down in revenue. And the neat trick is we circle the thing that's going to be larger in magnitude, and that tells us, comparing these two, this is the one that's larger. This tells you that revenue is going to go down. That's the kind of magic thing with elasticity. If we did an experiment the other way and we said minus 2%, percent change in price of minus 2%, which is going to go from 50 to 49. And I have the quantity go from 10 to 11. I'm going to have a percent change in quantity of plus 10%. Notice that the ratio is going to be the same regardless of which direction I go, because elasticity is kind of like slope. And now we also circle we compare the things, the percent changes. We look at the percent change that's larger. And in this case, since the quantity going up is larger, this means revenue is going to go up when we make this change. So let's think here. If I'm there and I move down in price and over in quantity, it's going to be moving to the right, and I'm going to move up in revenue. So this is the final amazing thing. There's no free lunch in economics. Whenever you raise the price, and you're not changing advertising and other things, you're going to drop your quantity. But elasticity tells you which direction is going to help you get more revenue and which direction is going to help you get less revenue. And it all has to do with percent. It all 100% has to do with percent. Now, I was going to give you a quiz, in-class quiz, but I didn't have time. So I'm just going to give this to you, and this is your check-in of whether something's solid or shaky. You can do this whenever you want, but I recommend you do it in the 2 minutes after class. And if you're shaky, come let me know. Okay, you do not have to turn this in. Okay, I'll just do one stack here and one stack in the back, and then you pick it up as you move. Ready for class?